Hello my lovely juniors, welcome back. Today we are checking about the week 2 and day 3. Here in your syllabus it is mentioned as give a presentation on an industry application to integrate VFD with the PLC. Now we will understand what is meant by integration and also PLC and how it will be integrated in the meanwhile details. So it is a part 1, how to integrate VFD with the PLC. So first we should know what is meant by PLC. It is a programmable logical controller, and if you see here the definition of PLC, next we should know, and what is a PLC? A programmable controller is a small modular solid state computer with a customized instruction for an performing a particular task. It means that, so here can you see one PLC? So this is mainly designed to make an work, any work which may be, it may be run in a manual or auto, it doesn't matter, but we will assign it to make a particular task. Here the particular task is running a VFD with the help of PLC, that one we will see now. So what is an integration? It is a process of combining two different systems in a single line aligned with each other. As you see these papers, so if I am aligning with one to another, both will be connected and it will make one system. Like that here we are connecting VFD with the PLC. So how we will connect? So this is it. What is the relation between the VFD and PLC? See, I will explain one thing. Here we have VFD and here we have motor. Mainly we use VFD to run a motor with a particular speed. Okay, here PLC is connected to the VFD. So first I will explain how the motor will work. See, as you know, in your homes also you have many motors, some motor or something. So you may use the two phase, right? So here for the industrial use, many times we will use the three phase power supply. So as we connected to the red, yellow and blue. So that's why the VFD also connected as three phase. Okay, and the same power supply will be given to the motor as you see here. But what is the role of PLC here? Now we will understand. As you see here, the speed, I will take the laser. So see, the speed power set point, it is called as HMI, human machine interface, means the machine is here. We want to give some RPM, we want to increase the speed, decrease the speed of the motor. So we will use this machine, that's why it is called as human machine interface. Okay, so in this HMI, just like your phone or something like that, for reference I am telling you, if I can increase the set point of motor here 100, 200, here RPM means rotation per minute. I repeat, rotation per minute. So before motor is running in the 400 RPM, so I want to increase the speed. So what I will do, I will give the 500 RPM. So what it will do, the speed set point from HMI to PLC by operator. The operator will give the set point and then PLC will take. So PLC what it will do? So PLC will calculate for 500 RPM how much current it should give. So what it will do, the speed set point from PLC to VFD, the signal will send, that is the analog output we will say. So that set point will come to the VFD and then the whichever the set point 500 RPM means it will check for the 500 RPM how much current it should send to the motor, then based on that motor will run. Think that if they want to decrease the RPM, again they will give 400, again it will send the analog output to the VFD saying that like we need less rotation per minute, so it will decrease the current to the motor, so the motor speed will be reduced. So how we, anyway we are giving set point that 500 RPM, okay, but how we know that motor also running in the same speed or not? So that's why we are taking the speed feedback from the VFD to PLC, and the same thing from PLC to the HMI we will take, then only we will know we are giving 500 speed and it is also running in the 500 speed. So that's it. You can explain this much only. It may be for 2 to 3 marks. Maybe in future I will explain in detail. In the part 2 we are going to explain the types of motors used in the industry. Okay, so in the next chapter we will learn this. Okay,